Alright, welcome to section 1.3, measuring segments. This is for GeoTrig. The essential question is, what can you do with line segments? And let's begin. So here's a postulate. It's called the ruler postulate. There's a lot of words in here, but basically what it's saying is when you have points, they have some kind of number or value, and we call this the coordinate. How do we use that? Well, one way is we can measure distance between points. So we got a bunch of, this is a number line, got a bunch of points. What is the distance between points A and B? One way you can do that is just count. How many hops? 1, 2, 3. So distance between AB right here is 3. And this is the notation we use. If you see AB italicized in the books, this means the distance between points A and B. That's notation. Now let's try AE. Well, A to E here, we can do it the same way we did last time in the hops, or if you want to do this mathematically, it's the absolute value of the difference of these 2 points. So the absolute value of -5 minus +5, the difference. And that comes out to -5 minus 5, so the absolute value of -10, which comes out to a regular 10. And as you can see when you do the hops, 3, 4, 5, 6, 7, 8, 9, 10, 10 hops, 10 points on the distance. Another thing with segments is the addition postulate. So if I have this line right here and there's 3 points on it, A, B, C, I can break this, the distance of point segment AB and the length of segment BC and the length of segment AC. What this says is if AB and BC are 2 parts of the line and B's in the middle, adding the length of these segments up adds up to the total length of the whole segment. It's just breaking it up into parts. AB plus BC equals AC. So how do we use that? Well, let's, for example, if the distance of AB is 5 and the distance of BC is 10, then AC is going to be 15. What if AB is 2x? And what if BC is 9x? Then AC would be 11x. Congruent. So congruent is a word we're going to use a lot in geometry. It looks like this sign right here. It's got the equal bars and it's got the squiggly line on top. So what is congruent? Well, it's used like equal, but it's used for figures and objects. So instead of equal, it's usually used for numbers. We use congruent instead when we're talking about the figures and objects in geometry. So let's take an example. I have these 3 lines here. We got line segment TS, and we got line segment WH, and we got line segment GH. It's not, shouldn't have used H. Let's call that GI. So we got GI, WH, and TS. Are these congruent? Well, if they're the same exact length, they're congruent. Let's see. I'm going to move this line WH and see if it matches TS, and would you look at that? They're the same thing, right on top of each other. So we can say TS, line segment TS, is congruent with line segment WH. Well, let's try this GI here. Well, GI, well, it's at a different angle, right? So that doesn't work. But wait, what if you rotate it? And then we move it on top? Oh, wow. GH is also congruent. We called that GI, I mean. Oh, geez. GI, right? So they're all congruent. Even if it's angled differently, they're still congruent. Moving on. Congruent segments have the same length. So let's look at this number line. I got the same 4 points as I did before. Well, let's come up with a few segments. AB equals 3. And we know BC, that's 3. And CE, that equals 5. Well, 2 line segments are congruent, AB and BC, so we could say line segment AB is congruent to line segment BC. Moving on. Midpoint. Midpoint, it's the point that divides a segment in half. So we got a line segment here with A, B, and C on it. You divide that in half at B. That means AC, AB is congruent with BC. You see these 2 dashed lines? That means these are the same length. These lines are congruent. You'll see that notation a lot. Here's an example. Pause the video, try it out. And let's solve this. So Q is the midpoint of PR. What are PQ, QR, and PR? Well, since Q is the midpoint, we know that PQ is equal to 5 is QR. So we can write that as an equation, 6x minus 7 equals 5x minus 1. Let's solve for x. So first thing I'm going to do is subtract 5x to both sides. When I subtract 5x, I'm going to get x minus 7 equals negative 1. Then I'm going to add 7 to both sides, and I get x equals positive 6. So if x equals positive 6, we got to solve for PQ. PQ is going to equal 6 times 6 minus 7, which is going to be 36 minus 7, which is going to be 29. So that's PQ. Well, QR. QR is going to equal 5 times 6 plus 1, which is 30 plus 1, which is going to be 31. And PR is adding both those segments together. So that's going to be 29 plus 31, which is 60. Next one. All right, pause the video. And 3, 2, 1. Here we go. If EG equals 59, what are EF and FG? So EG, this whole thing, equals 59, this whole distance right here. Well, that means that these two segments right here have to add up to 59. So we have 8x minus 14 plus 4x plus 1 equals 59. All right, combine like terms here. I'm going to get 12x minus 13 equals 59. Going to add 13 to both sides. If you add 13 to both sides, you're going to cancel on those 13s, and you're going to get a 2, carry 1, that is 72. So 12x equals 72. My last step here is divide by 12. Cancel on the 12s, you're going to get x equals 6. So if x equals 6, then I got to find, I'm not done with that. I got to find EF and FG. Well, for EF right here, I know EF is going to equal 8x minus 14, so 8 times 6 minus 14. 8 times 6 is 48, so 48 minus 14, well, that's going to be 34. And over here for FG, FG equals 4 times 6 plus 1, so that's 24 plus 1, which is going to be 25. That's it.